Dear students, in earlier session, we discussed about the mechanism of mono substitution reaction. Okay, mono substitution reaction. So electrophilic substitution reaction in that mono derivative. So mono substitution reaction we discussed in the mechanism. We are discussing mechanism. Its mechanism of nitration we discussed in the earlier session. In this session, we'll continue from the mechanism of the sulfonation reaction, mechanism of sulfonation of benzene. So we know that sulfonation reaction, benzene are treated with concentrated sulfuric acid, which forms C6H5SO3, HSO3, and with the formation of H2, that is a reaction. How it forms? So this mechanism, sulfonation, nitration, halogenation, Rillcraft alkylation, acylation, has three steps. First one, step one, formation of the electrophile, generation of electrophile. In generation of electrophile, how concentrated H2SO4, H2SO4 sulfuric acid. The two molecules of sulfuric acid in it so dissociates as will be forming H3O plus HSO4 minus plus SO3. So SO3 is electrophile. SO3 is electrophile. Electrophile means electron deficient. You're thinking, why not H3O plus an electrophile? Why are we considering SO3 as an electrophile? Sulfur atom in sulfur trioxide, sulfur in SO3, sulfur is only having the 6 electron. 6 electron we call as sextet electronic configuration. Sextet electrons. Therefore, the molecule is electron deficient. They act as electrophile. So SO3 will be forming. So first step, generation of electrophile. SO3 is generated. In second step, formation of intermediate carbocation means aranium ion. So in that, the electrophile should attacks on benzene ring. So C6H6 is benzene. For our convenient, we are writing only one hydrogen to represent. Means all the carbon will be consisting hydrogen. So SO3 electrophile attacks on benzene. So why it attacks on benzene? Because electron rich pi electron will be present in the benzene. So where the pi electron, there it will attacks. So we'll be getting this the product like this or intermediate like this benzene ring, and here an hydrogen para position or SO3 and H. And if it adds here means hydrogen adds to this carbon is an sp3 hybridization now. So bond will break. The bond will break between them. Here the electron deficient as usual earlier, like here is a double bond and here will be the double bond as it is. Here will be one double bond, another two double bond. But here what will happen? So in here, so there will be electron density. There will be electron density. So here is an electron density. So positive charge. This what happened? Delocalization. It will be stabilized by resonance. Which will be stabilized by resonance. How will I'll tell you, then I'll write step by step. So here the pair of electron, if the pair of electron, if SO3 attacks here in this position, then it forms an electron deficient group. This pair of electron shift here and here will be forming positive charge. One step. Okay, and after that, so I'll write all the three how they'll be forming. So with this one benzene ring. So in this benzene ring, here hydrogen SO3, there is no change in it, SO3 and hydrogen. And this electron double bond, if shift here, so will be forming positive charge. So here as usual double bond. Then this double bond will shift here and will be forming here the positive charge. Delocalization of electron will take place. So then if we shift here, so electron diffusion for the carbon here, so we'll be forming positive charge on the orthocarbon now. So here is double bond and this electron shift here will be forming double bond. Here is positive charge and hydrogen and this is SO3. Now to drag the pair of electron from here, there is no pi electron. So conjugation means, so delocalization of pi electron stops here because this carbon is under sp3 hybridization. Now what happened, these three equivalent structure, all these three equivalent structure we can able to write like this: benzene on benzene. I need to write, so here on benzene, on hydrogen, and SO3 is here. So we'll be having the positive charge. Positive charge is relocalized from here to here, but not a complete circle because this carbon is an sp3. This carbon, hydrogen, and SO3. Carbon, carbon, single bond, no sp3. So there is no delocalization of pi electron. So we'll be getting like HSO3 minus and H. This is how we are getting. So this is what we form. What it forms: uranium ion. Uranium ion or intermediate carbocation. This formed intermediate carbocation loses hydrogen or donation of proton. Donation of proton, this is a product. This product is treated with in the third step. Step 2 is over, formation of carbocation. Now we need to take the same, the product is step 3. This will be treated with what is the intermediate, sorry, what is the beginning? Will be forming HSO4 minus SO3 H3O plus. HSO4 minus drag this hydrogen, take this hydrogen. So HSO4 minus and H, it becomes H2SO4. So combining faster. The combined fast will be forming H2SO4 along with that with the formation of SO3 minus. SO3 minus and plus H2SO4. Now SO3 minus H2SO4 is stable now. This SO3 minus along with that will be having hydronium ion, no, H3O plus. H3O plus donate a proton to this, will be forming H2O and the product will be formed as C6H5SO3H benzene sulfonic acid with the formation of water. So C6H5SO3H is called benzene sulfonic acid. This is how reaction will take place. First one is generation of electrophile, second one is formation of uranium ion, third one is donation, removal of proton H plus. Okay, so loss of proton or removal of proton. This is how sulfonation will take place. As like sulfonation, and halogenation. And halogenation, again, you know the general equation. Don't want to write once again general equation. In the general equation, 3 steps halogenation. So first one is generation of electrophile. So between Cl and Cl, this will be treated with a catalyst like perchloride. So Lewis acid. So it will take an electron, means it will take chlorine from along with FeCl3, will be forming FeCl4 complex ion, FeCl4 minus along with that Cl plus. The Cl plus is called chloronium ion. CHLOROIUM, chloronium ion. CHLORONIUM, chloronium ion. Then this chloronium ion attacks on benzene ring. Second step. This chloronium ion, what it forms in Cl plus, this attacks on benzene ring. So here hydrogen and double bond, here double bond. So if it attacks on this Cl plus, where it attacks electron rich group, means double bond, it attacks to any double bond, it will be getting the same product. So it will be getting the resonance structure. So resonance structure again doesn't require to write. Just I will tell you. I look here. So I'll in the color and I'll right here. So how it will be? So if it adds to here, chlorine attaches to this. So now it is an sp3 carbon. So we'll be forming positive charge. After the formation of positive charge, this electron comes here. So here we'll be moving the positive charge, deficiency of an electron. So again, this electron move here deficiency of an electron. So hybridization stops here, sorry, stabilization, delocalization stops here. We'll be forming uranium ion. So I'll write directly what it forms, the uranium ion, all the three steps, what I said in the earlier, all the three steps. The positive charge from this carbon to this carbon, delocalization of electron, and one with hydrogen and another with Cl. Okay, this is uranium cation, uranium ion or benzene cation. So carbon and carbon cation. In that, the formed uranium ion, third step, in that the removal of proton should take place. Removal of the proton when we take an halogenation. So this will be the treated, means this product here, the positive charge. So the positive charge here, one is hydrogen and the chlorine. This will treat with the FeCl3 or AlCl3. So FeCl3 or AlCl3, it will take this hydrogen. If it takes this hydrogen, chlorine and hydrogens to form HCl and will be forming, sorry, FeCl4 minus. No, that is not FeCl3. This is FeCl4 minus, because what it forms is FeCl4 minus product. This FeCl4 minus takes hydrogen, will be forming C6H5Cl, monosubstituted chlorine. Okay, and one hydrogen, if it shift here, it forms a double bond, here double bond, here double bond, with the formation of H and Cl, HCl, and the formation of FeCl3. So we'll be forming chlorobenzene. So this is chlorination, mechanism of chlorination, or especially example mechanism of halogenation. Cl is replaced by X, then you'll be getting halogenation. Next, mechanism of Friedel-Crafts alkylation of benzene and acylation of benzene. Next is Friedel-Crafts alkylation first. Next we'll see acylation. Alkylation is alkyl halide. In the first one, generation of electrophile. So methyl chloride CH3Cl treat with a catalyst like AlCl3, aluminum chloride. So aluminum chloride takes chlorine to form AlCl4 minus with the formation of Cl positive charge. Cl positive charge. So not Cl, CH3 positive charge. CH3 positive charge. That CH3 positive charge is called methyl carbocation. Methyl carbocation. So this methyl carbocation is electrophile now. This electrophile attacks on benzene ring will forms uranium ion. So this benzene ring hydrogen will be having double bond, one double bond, and one more double bond, three bonds. So if attacks, this electrophile attacks on CH3 group where the electron rich. So if it attacks an electron rich group, so we'll be having the possibility. What are the possibilities? So this carbon, now this carbon is in sp3. If attacks, no. So we'll be forming here hydrogen, and here is a methyl group. So it's forming positive charge. Double bond and double bond is here. Then if the pair of electrons shift here, this will be turns to getting another structure, positive charge. Right? Then after that, this pair of electrons shift here, will be getting the positive charge here. So it stops here only because there is no conjugated pi electron. So with the equivalent to all these structure, I'll write this structure, single structure. So benzene ring in that. So the double bond here, the moment of positive charge, here the positive charge, delocalization of electron, here is a hydrogen, and here will be CH3 group, methyl group. Okay, so this is sp3 carbon. The step is slow, hence it is called rate determining step. Step is slow. Why? Because sp3 carbon delocalization will stop here. So hence it is this step, formation of uranium ion is the slowest step, hence it is called rate determining step. In any chemical reaction, slowest step is considered as So rate determining step. After the formation of the carbocation, after the formation of uranium ion, then the removal of proton, losing a loss of proton needs to take place. So what happened? The proton needs to remove from this. So here, so I'll write the product. The ion, uranium ion, positive charge here, delocalization of electron, hydrogen, and this is CH. Okay, so this is treat with AlCl4, AlCl4. Okay, so AlCl4 minus form product. No, in that it will take hydrogen. AlCl4 take hydrogen will be forming this product. This electron will be left behind. This will shift here. Will be forming double bond and one more double bond and double bond with CH3. C6H5CH3 is called toluene. Along with the formation of H and Cl, HCl plus Al plus Cl3, AlCl3. So this is how the halogenation reaction will take place. Okay, but you need to remember here, especially in halogenation reaction, one important point you need to remember, considered as a important point. When all the alkylation is carried out with higher alkyl halide, example N-propyl. N-propyl means carbon number 3, normal propyl chloride, N-propyl chloride. Then electrophilic formed in the first step is primary carbocation. What it forms in electrophile in the first step, generation of electrophile. Generation of electrophile should be primary carbocation, that is CH3. Next is CH2. Next is out of CH3, one hydrogen is removed, CH2 plus. This is forms primary carbocation. Being an extremely unstable, this carbocation is unstable because it's 1 degree carbocation. Compared to 1 degree and 2 degree, 2 degree carbocation is stable. So it is unstable. Due to extremely unstable, it changes to a more stable structure, more stable arrangement. Because what happened? So 1 degree to it changes to a 2 degree. To changes to 2 degree. So what will example? If you consider this, I'll write CH3, CH, hydrogen, CH and CH, CH2, and it becomes CH2 plus. So this is first 1 degree carbocation or primary carbocation. So this hydrogen shift to this on this carbon. If it shift to this carbon, okay, shifting is also we call as rearrangement reaction. Rearrangement reaction. In that rearrangement reaction, 1 and 2, 1, 2 hydrogen will be shifting. So it is called 1,2 hydride shift. 1,2 hydride shift. Then it will be forming CH3, CH3. This hydrogen shifted there. So electron deficient, one hydrogen, one bond is required, CH plus. Now what it forms is secondary carbocation, 2 degree carbocation. And here is primary carbocation, 1 degree carbocation. Second degree carbocation is more stable than primary carbocation. That is the reason which attacks on benzene ring. So in primary carbocation is unstable, hence we cannot get the product. So if it is an electrophile, attacks on benzene. If it attacks on benzene, how will we getting CH2 group from reverse? CH2, CH2, CH3. This is called 1-phenyl propane. 1-phenyl propane is also called as propyl benzene, is unstable, doesn't exist, is not possible to get, because this rearrangement will take place and will be getting benzene alternate double bond in that. So secondary carbon here CH, one side CH3, another side CH3. So what it is? 2-phenyl propane. 2-phenyl propane. 2-phenyl propane is called isopropyl benzene. Isopropyl benzene. Isopropyl benzene, also known as cumene. This is we discussed while in the nomenclature. You need to remember cumene. Isopropyl benzene is also called as cumene. So it is most stable. 2-degree compound will be formed. 2-degree carbocation will form. So this we call as 1,2 hydride shift. Why this will be happen? Because 1-degree carbocation is unstable, extremely unstable. So it will be forming secondary carbocation. So you need to remember one of the important point. Okay, 1,2 hydride shift. So next, that relates to alkyl halide. Next, mechanism of Priddle-Crafts acylation. Priddle-Crafts, ACYLATION, acylation. So in the acylation, that's RCOCl. RCOCl is acyl group. RCOCl. In the first step, generation of electrophile. In the first step, so formation of electrophile from acetyl chloride. Acetyl chloride is CH3C double bond O, and this will be Cl. This will be treated with a catalyst like AlCl3. Al, just a minute, I'll erase this. So AlCl3. So AlCl3. So it separates this chlorine, combines together, will be forming AlCl4 minus complex ion. And along with that, the formation of C double bond O CH3, and deficient of an electron will be forming positive charge. Positive charge, this is called acetyl carbonium ion. Acetyl carbonium ion. Acetyl carbonium ion. CH3, C double bond O plus. Okay. And this acetyl carbonium ion, second one, attacks on benzene ring. Attacks on benzene ring, which will be forms the cararanium ion, intermediate of carbocation. So this benzene, C6H6, one hydrogen. 2, this means all the carbon will be consisting hydrogen, need not to get worried. So C double bond O and CH3. So positive charge. This positive charge should attacks on the carbon rich group. If it attacks on carbon rich group, again it will be stabilized by resonance. So I'll write equivalent structure, because and earlier we have written 3-4 times the same structures, right? So now this pair of electron, what happened? So if it hydrogen, and how we will be getting? So one hydrogen, another C double bond O CH3, like this we are getting. And it will be stabilized by resonance. If it will be stabilized by resonance, we'll be getting a structure, means positive charges keep on changing their position, plus 1 here, and after that 1 here, next time in ortho position, and this delocalization that takes place. So we can write oxygen with semi-circle. So this is aranium ion or carbocation. This carbocation intermediate removes proton, loses proton. The removal of proton, how it will takes place? I'll take this intermediate carbocation, positive charge, delocalization to this carbon. Here we not completed, because this carbon is under sp3 hybridization. Now C double bond O CH3. So this will be treated with AlCl4 minus. AlCl4 minus drags in hydrogen, right? Will be forming H and Cl. HCl, okay? HCl plus AlCl3 plus benzene C6H5. Okay, here this hydrogen, no, this will be shift here, forms it one double bond, here one double bond, and here one double bond. Will be forming the 3 double bonds, and will be substituted as this C double bond O, C double bond O, CH3, C6H5, COCH3 is RC double bond O R dash, that is acetophenone. Acetophenone with the formation of HCl and aluminum chloride. This is the reaction, means Priddle-Crafts alkylation reaction. Priddle-Crafts alkylation reaction. Are you getting? These are the mechanisms. These are the mechanisms of So in this session, what we discussed from sulfonation, halogenation, Craft alkylation, and acylation reactions. Okay, so next, and after this, we need to study about the other chemical reactions, means chemical property of benzene. This here we are discussing the property, chemical property. In that, the first one is electrophilic substitution reaction, right? We are in electrophilic substitution reaction. In electrophilic substitution reaction, we studied mechanisms, benzene, arene mechanisms. Okay, next. Second reaction is addition reaction. Is it clear? All these steps should be clear. Okay, next. Addition reaction. In addition reaction, addition reaction of benzene, high temperature or in pressure, or a high temperature or in pressure, in the presence of nickel catalyst, hydrogenation of benzene gives cyclohexane. Hydrogenation addition. So hydrogenation benzene. So 3 moles of NH2 will add to 3 moles an alternate double bond. So with alternate double bond will be forming in the presence of nickel catalyst. Nickel catalyst will be forming the single bond. A double bond reduces to single bond will form cyclohexane C6H12. C6H12 compound cyclohexane. Okay, so in that addition of hydrogen, dihydrogen, so hydrogenation reaction. Instead of that halogen, we can add an halogen on the benzene ring or a treat with a halogen X, so like Cl2, Br2 or I2. So usually chlorine and bromine are preferential. When we treat with halogen like Cl2, when we treat with Cl2 or Br2 or I2, so in presence of anhydrous aluminum chloride AlCl3 at 300 to 320 Kelvin temperature. So what happened? This chlorine will be substituted on the benzene. One of the hydrogen, means hydrogen combines Cl and Cl. Okay, so it's not need. So here this benzene C6H6. In this benzene, treat with halogen like Cl and Cl2. So hydrogen will be replaced here, and hydrogen combines with chlorine to form HCl, and this hydrogen